Here we're going to talk about the superposition of waves, and we see this when waves combine and interfere with each other. So the principle of superposition tells us that when two waves meet, they will have a net displacement. And the net displacement of the medium in which they propagate at the point, any point where they meet, will equal the sum of the displacements of the two waves in the medium at that point. So in other words, we're going to add the waves together. We can see in this diagram that we have a wave with small amplitude combining with a wave that has a larger amplitude, and over time, as they combine, we get a wave that has a larger amplitude, and that's because both of these waves are positive. We would see a different result if one of those waves were negative. Alright, so on the accompanying worksheet, we're going to get some practice. So sketch the shape of the wave pulses when the waves are half on top of each other and then completely on top of each other. So those are the first two pulses that you see on the sheet. Now I'll pause the video and give it a try. Once you've tried it, then you can resume the video and see how you did. Alright, when the waves are half on top of each other, then we see a waveform that looks like this. Because when they're half on top of each other, this part of the left wave is combined with this part of the right wave, and you get a tall box right here where they combine. So they add together to give you this form. This part right here and this part right here are just left over. So you see those just sitting on the left and the right hand side right there. In part B, when the waves are completely on top of each other, you have this entire box or rectangular waveform stacked on top of this entire rectangular waveform, and you get a large rectangular waveform with twice the amplitude. So it's twice as big. All right, now try the rest of the practice on that sheet. Pause the video again, and then you can resume when you're done, and we'll see how you did. Here we've got one positive waveform with one negative waveform. When the waves are half on top of each other, we're combining this part of the wavefront with this part of the wavefront. So this little box here with this little box here, but one's positive and one's negative, so we get zero displacement. So that's zero. That should be a straight horizontal line. What's left over is this part of the form and this part of the waveform. And so that's here and here. So we see that they're left. They haven't interfered with each other yet because they haven't overlapped. In part B, when the wave overlaps entirely, it means that this entire positive waveform is overlapping this entire negative waveform, and 1 plus negative 1 gives us 0. So the displacement is 0 in that case. Keep in mind that since these waves are propagating, they're moving. That means that this will only happen probably for a fraction of a second, and then they'll just keep moving in the same direction. This interference does not happen permanently. It only happens when they overlap. How about this one? We've got a couple of negative portions of the waveform here and here. When they overlap, we get a large negative displacement like this. And then these parts are left over. So this waveform and this waveform are still here, so far unaffected. Once the entire waveform overlaps, we've got a negative and a positive and a negative, and it combines with a negative and a positive. So that means we get zero displacement in part B, where they completely overlap. Now if we move in 2-second intervals, we see something like this. So after 2 seconds, and each one of these boxes right here, so each one of these jumps represents 1 second. So after 2 seconds, we see this. After 3 seconds, after 6 seconds, we see this, and we can see that there's a jump of 6 from the start. So there's the start, and there's the position now. So it's gone 6 seconds, and now we're starting to see some overlap. So that means that this waveform, this part of the waveform on the right is overlapped with this part of the waveform on the left, and we get a larger displacement. So the displacement is twice as great in the middle there, where those two parts of the waves have overlapped. Once they completely overlap, because we have a positive and a negative here, and then a negative and a positive there, then when they combine, we get zero displacement. So this is where the waves have entirely overlapped. That's at 8 seconds in. For this one, it looks a bit different because these two waves are oriented in more or less the same way, where we have the positive part on the left and the negative part on the right. So 5 seconds in, we see that we get some overlap. So these two parts are partially overlapped. So if we draw a little diagram here, we've got this part of the wave is overlapped with this part of the wave. So if we look at the beginning here, that's the start of the first wave. 5 seconds in puts us here. So that's the start of this interval there. So 5 seconds in. So where they overlap, we've got the negative here and we've got the positive here, and so we get zero displacement for those, for that combination rather. The rest of the wave is unaffected so far. 6 seconds in, we now have this entire wave front. I'll just erase this for a second here. Start again for this one. So for 6 seconds in, we have this entire part of the waveform interfering with this entire part of the waveform, and so they add to give us zero displacement right here. And again, the other parts are unaffected, so this part and this part are unaffected, so they stay right there and right there. At 10 seconds in, this part of the wave has moved another 4 places this way. This part of the wave has moved another 4 places this way, so they interfere to give us zero displacement. But the two parts of the wavefront, right here and right here, that interfered originally are now back after their interference. So this, I'll just erase this. It's getting a bit messy here. So the part that I'm erasing shows those waveforms before they interfere. So right here, This is what they look like before they interfere. After they interfere, they continue to move in their respective directions. So here we have a negative waveform that's moving to the right. Here we have a positive waveform moving to the left. After they're done, we've got a positive waveform moving to the left and a negative waveform moving to the right. So this is just this, but it's after the interference. And this is just this after the interference. So after they interfere with each other, they just keep on moving, and they are not permanently affected. They go back to the way that they were before the interference. And that's a look at superposition of waves.